So let me start by sharing the screen.
I've just started the recording.
That's great. Okay, cool. So it came true. You can see my screen out, right?
Yeah, I can.
Okay, awesome. Well, hello everyone. My name is Robin. I'm a solutions architect at AWS. I work in the Benelux region. I'm actually located in Amsterdam. So for me, it's 6 p.m. now. Where are you all based? Can you put something in the chat? Houston, Texas,
Hi
Colorado.
Robin, I'm based out of India. It's 10:35 p.m. Indian Standard Time.
Oh wow. Okay. So all over the globe, apparently. That's good. Okay. Cool. So today we're gonna talk a bit about DNS. So before we dive into like all of the AWS specifics, just wanted to quickly recap what DNS exactly is and what it's used for. So in this scenario, we have like our little stick man called Bob, and Bob would like to go to a domain name. Now he tells his computer that he wants to go to this like domain name, but like computer networks, they don't understand like letters. They usually talk using IP addresses. So Bob has to have a way to like exchange this domain name for an IP address. So what he first does is he checks his local cache. In that local cache, he doesn't find anything, which is called a cache miss. So he then asks his non-authoritative DNS server, which also has a cache. This like setting is usually found in your network settings. Like if you're on Windows, you can usually find it by clicking on the like network item in your taskbar on the bottom right, and then going to network settings and finding out your DNS server. Usually it's something that like your provider gives you, or it's maybe Google's, which is like 8.8.8.8, which is a commonly used one. But these types of DNS servers are called non-authoritative because they don't have the definite answer. The answer is actually stored somewhere else. They just keep it for a set period of time, which is what the cache is used for. But actually, we want to break this domain name down. So robbieverse.dev is a domain name that we'll use throughout the session. And we actually want to break this down a little bit. So we can actually break it down in 3 parts. We have, obviously, like we have the TLD, so the top level domain, which is called .dev. And then on top of that, we have our dot. And this dot is usually not something that you see in like domain names typically, but it's called the root domain server. So actually behind every domain name that you like look up or that you put into your browser, there is this little dot. It's invisible to you, but it actually exists. And why this is important, we'll see in a minute. So the non-authoritative DNS server will actually do some sort of a recursive lookup. So it will see whether it has something for robbieverse.dev dot in its cache. If it doesn't, it will look for do I have something in .dev dot in my cache? Also not the case. It will look for the dot. Do I have the root domain servers in my cache? He also doesn't. So in this case, we start from a complete scratch DNS server, which usually, like in a typical world, is not the case. But let's do that for now. So the first thing that we have to do is we actually have to reach out to one of the 13 root domain or DNS servers around the globe. They're spread all across around the globe, and they're maintained by an organization that is not for profit, and they basically make sure that the internet works. So what we request is basically we ask these root DNS servers, where can we find robbieverse.dev? And they tell us, we don't know. What we can tell you is that you can find .dev somewhere else. So we'll send you those addresses. So our DNS server is then like, okay, we'll look for .dev in this case. So we'll reach out to those DNS servers, and again, that's called a TLD or top level domain, right? Because it's kind of on the top level besides the root. And we'll ask there again, like, do you have an IP address for robbieverse.dev? And again, the answer will be no, but we have the location for robbieverse.dev. We have the name servers for them, so you can actually go ask there. And then finally, we'll go ask those domain servers, and these will respond with the final authoritative answer. So this is actually the difference between non-authoritative and authoritative. It's that this like end result or this destination actually has the DNS record, and it's defined at that level. Okay. I hope this made sense. If you have like any questions throughout the session whatsoever, like feel free to put them in the chat or just unmute yourself and speak up. Fine handling questions at any point. So we'll actually split up the session and I'll jump back and forth between presentation and demo and presentation and demo to kind of make it a bit more interactive, that you don't get like bored by PowerPoint. So we'll actually use the terminal in a couple of demos throughout the session. The first thing we'll do is we'll actually try to look up a domain name. So yeah, I can show the previous screen again. There you go. Is that all right? Yeah, okay, cool. All right, so what we'll do is we'll actually take a look at the IP address for a domain name, right? So we'll use a utility called dig, and that's available usually on Mac and on Linux. On Windows, you have a similar command-like utility called nslookup. So nslookup. But for now, we'll use dig, and we'll just look for DNS records for Amazon.com. And what we get back is indeed in this answer section, we get back the IP addresses for Amazon.com. Okay, what we can actually also do with dig is this really cool like troubleshooting tool, which is called dig trace. And what we'll do is we'll trace robbieverse.dev. And this will actually walk us through this whole life cycle. So you'll see a lot of text on the screen appear, right? But let me walk through this and explain a little bit. So what we're seeing here is basically the whole workflow from the root DNS server to the top level domain to actually getting to the robbieverse.dev, right? So yeah, first thing we'll do is we will reach out to an IP address that is statically programmed into our computer that will this is one of the root domain servers. So the top server that we saw in the diagram just now. And we will actually ask this root domain server, give me a list of all root domain servers. And so we will get a list of all of these root domain servers. We will then randomly pick one, just randomly, In this case, we picked c.rootservers.net, so this one, and we will ask again the same question, like what is the IP address for robbieverse.dev? In this case, they exactly respond with the same thing, like we don't know, but check here. So these are the name servers for .dev, right? As you can see, .dev, name server. So again, we'll do the same thing. We'll pick one of these. In this case, we picked TLD3, so this one. And we'll ask the same thing to the dev name servers. We then get our responses back, which says basically, okay, go ask AWS. And when you see this AWS DNS domain name, that usually means that it's hosted on Route 53. And so in this case, we'll pick, again, one of them. We'll ask the same question, where can we find robbieverse.dev? And we'll actually get like a response that is pretty useless to us. It's called a SOA record or a startup authority. It's usually just like a very informative record, like usually administrative. It isn't really used for anything. So if we actually simplify this whole like lookup and we just look up robbieverse.dev, we'll actually see that in our question section or our answer, we get nothing, right? Because currently we don't have anything defined. That's what we'll do in a demo a bit later on. But as you can see, like this indeed walks through the whole setup of querying the root domain servers, querying those dev DNS servers, and then finally querying Route 53. Okay, so we brought up Route 53 a couple of times. What does Route 53 exactly do? And in technology, I think it's really interesting. A really interesting observation that someone once told me is that technology is all about influencing and manipulating behaviors. So in DNS, what we want to do is we want to manipulate the behavior of a person requesting a domain name of something, right? We want to return a certain value to them, and we want to be able to manipulate that value. And we'll do that through two main things that we can do with Route 53, which is one, domain name registration, which will influence the behavior of number 2, so our top level domain. And we can do that through public authoritative DNS. So that is influencing all the behaviors of 3 and below, right? So 3, 4, 5, we can like build up a whole section of subdomain names, as we call them. So for example, if you go to your AWS console, you can see console.aws.amazon.com or something like that, right? So layer upon layer upon layer upon layer. So that's what we influence with public authoritative DNS, which is also a feature of Route 53. We then have private hosted zones, which we won't talk too much about, but it's basically doing the same thing, but then for internal DNS. Route 53 resolver is also a feature which is usually used when combining with on-premise environments. But again, we won't go into that in too much detail. So let's start with registration. But before we do that, any questions on DNS in general? Anything that we've covered so far? Nope. Okay, great. All right. So let's go again with Bob. And Bob, in this case, wants to register a domain name. So what he does is he goes to, oh, you can't hear anything. That's weird. Yeah, will. Oh yeah, probably audio settings in Chime. Hopefully Anthony can hear us soon. Okay, so what Bob will actually do is he will talk to a registrar. So Route 63 is one of the available registrars out there, but there are many, many more. And he will actually ask for a domain name. So he will give some information. He will give the name that he wants to register. He will give the top level domain, so .com, .net, .dev, etc. And he will give it, or the registrar, his contact details. And the registrar really just is a man in the middle, right? The registrar won't do anything but hand that information over to another provider, which is in our case, our top level domain, right? That top level domain will receive a bit of a different information, right? So we reach out to that top level domain. We again give it the name that we want to register. We give it our contact details or anonymized contact details. So our registrar usually has an option to anonymize our contact details. And it also gives these name servers out. So this is actually the thing that we received here, right? So these things are what are records that are being set when we register our domain name. Because again, our names or our top level domain. So in this case, this roadregistry.com has to be able to return something, right? It has to be able to tell our client, you can find the next step over here. And so that's what we're defining in our top level domain, or when registering our domain name. So with Route 63, you can register a lot of domain names, 272 generic domain names, and 49 country domain names. So I saw someone from Germany. You can register a .de domain name, right? You can also register like the generic domain names, which are .com, .net, etc. Okay. When you register a new domain, you can, it's usually a 3-step process. So first of all, you choose an available domain name, you add it to your cart, you define the contacts for the domain name. You either enable or disable automatic renewal. So usually a domain is registered for a 1-year period. What do you want to do after that 1 year? Do you want to renew it automatically, so extend it for another year? Or do you want to not do that and just let it expire? And then you finally select the privacy protection preferences. So whether you want to do that anonymization or not. Secondly, Route 63 will actually, this is actually, the first step is actually everything that you have to do, right? So from that point on, like Route 63 takes care of step 2, which is it picks these name servers and it hands them over to the top level domain. And also it creates these public hosted zones. Then step number 3 is what we'll get into later, which is actually the zone or the record creation. So actually influencing that point 3 and below. Okay, so we'll dive into another quick demo. So we'll actually show you what it looks like to register a domain in Route 63. Okay, so in the Route 63 dashboard, you can go under domains, and then you can search for the registered domains or go to this registered domains. Yes, I can zoom in a little. Actually. Here, yeah, so that's a little bit too much. Okay, should be better, right? Okay, cool. So down here, you can register a domain. And then you can choose a domain name. So let's say restart webinar. Check if this domain name is available. Oh, unfortunately it isn't. So we'll just add a couple of random numbers at the end. We'll check again. And restart webinar 156, etc.com is available. So we can add this to our cart. We can then click this continue button. And then we can fill in all of our contact details, and we can disable or enable privacy protection. And this is really all we have to do to get a domain name. Yeah, third step is just verify and purchase. So we won't actually go through it, but you get the point, right? Another thing I want to show you, because it's kind of cool, is that once a domain name is registered, you can actually find out quite a bit of details about the domain name. This is all public knowledge or public referenceable information. So if you want to find out where the domain name is registered or who registered the domain name in some cases, you can actually find that information out. And we can find it out using the whois command. So literally asking who is the owner of this domain name, who is the registrar of this domain name, who or what are the name servers of this domain name, right? That's all the information that you can find out using the whois command. So we'll actually look for Robbieverse dev. And again, we see loads and loads of information. So we'll scroll up a little. Okay. So the first thing we can see is that the dev top level domain is actually owned by Google. So Google actually has this top level domain. They're the owner of it. What we can also see is registrar information. So where did I register this domain name? I registered at not at registry because it was before I joined Amazon, but I registered it at Namecheap Inc. I created the domain name in July 2020, and it expires in 2022, also July. So I paid for my first year, and then after a year, it automatically renewed, and now I have it for a second year, right? That's really all the information that you'll find out because I enabled the privacy setting, so you won't be able to see a lot of the other information like my personal address, etc. What you will be able to see is those name servers again. So you can find those out using the whois command as well, because that's, again, information that is owned by the top level domain. Okay. I don't want to go into too much detail on transferring domains. Just for now, know that it's possible. Like you can bring a domain that's already registered from another provider to AWS. You can also move it away from AWS, which I don't know why you want to do it, but you can. And you can also move it cross accounts using domain transfer procedures. There are loads of resources online if you're ever in that situation. Okay. Any question before we actually start playing around and influencing some behaviors? Yes. So there somewhat is a fee. Usually when you move a domain name from one registrar to another, you pay for the full year at that other registrar. So there isn't a fee per se for moving. It's just that, for example, my domain name expires in July. If I move it now, I'll have to pay now. So if I move it to registry now, I'll have to pay I don't know, $12 or something to Route 53 now. and I'll have to, or my domain name will expire exactly 12 months from now. So in February instead of in July, right? So actually missing out on a couple of months of, domain name. Yeah. So usually if you move domain names, it's best to do it close to the expiry date.
Hey Rob,
Yeah. Hey.
this is TJ. Nowadays we can able to publish our domain name directly in the internet. Why do we need to update that into AWS kind of? What is the purpose of that?
So the purpose of what do you mean exactly? Updating your domain name in AWS?
No. You're saying we can tie up with the AWS. Just one slide back, you are explaining that we have to update that into AWS, right?
Let me move a couple of slides back. Do you mean
Yeah,
this one?
the one before. There's a one slide. Yeah, transferring
Mhm.
external to AWS. Why do we need to do that?
You don't need to.
Okay.
So if you want to use Route2C3, Route2C3 actually has two components to it. So it has the registrar where you can like buy domain names and renew domain names, and it has the DNS component, and they're kind of separate. So what you can do is you can tell your current registrar. So in my case, I told Namecheap, I want my DNS records to be on Route2C3, and I just handed them new name servers to reference to. So in that case, like my registrar and who I'm actually paying money to will actually be still Namecheap, but my DNS hosting will be on AWS and will be managed by Route2C3. So those are
Oh,
actually two different components.
okay, got it. Thank you, Rob.
Sure. I see another couple of questions. Are all domain names standard fee of $12? Truth be told, I don't know. I've seen like with other registrars that domain names vary a lot from like a couple of bucks, even like $1 to all the way up to like thousands of dollars if you run a really, really exclusive one. So yeah, it can vary a lot. Can I define a DNS in AWS and host the application on an on-premise infrastructure? Yes, you can. So you can actually, as we'll see in a minute, change the DNS record, so the value that DNS returns, to any IP address in the world, right? So you can even link your domain name or return the IP address of Google.com, right? When you actually browse to your domain name, you won't be redirected to Google.com because Google has a couple of protections in place to make sure that that doesn't happen. But it will actually be possible. Like you can manipulate DNS in any way you want. Are we able to access these PowerPoint slides after the webinar? That's what I'm going to look to the restart team for, but we'll try to get them to you. Okay, so authoritative DNS. So there are two ways of doing authoritative DNS in Route2C3. First way is using public hosted zones. So this is what we've done now, like registering a domain name and making sure that we have our DNS resolving, right? Then we have private hosted zones, and those are only accessible within your VPC in AWS. The reason you would want to do that is a couple of things. So for example, you have an RDS database that's in AWS. And as you might know, once you restore a snapshot from an RDS database, it gets a different DNS name. It gets a different domain name. You might not want to update your application every time that you restore a snapshot from RDS, right? So instead of changing the application code to actually point to the new domain name, you can just change a value in Route 53, and your application will automatically be redirected to a new domain name or to the new RDS endpoint, which is just one example. There are many, many more for using private hosted zones. Okay. So as we'll see in a minute in the demo, we actually have a couple of record types that you can choose from. So there's one very, very unique one in Route 63 that you'll only find in Route 63, which is an alias record. And alias is very unique in a way that it resolves the DNS endpoint of another resource, so of another domain name, in the Route 63 server itself, so in the Route 63 ecosystem itself. It's a bit hard to grasp if you don't know what a CNAME record is, but basically a CNAME record, it's better than a CNAME record in a couple of ways. First of all, you can't use a CNAME on the root of your domain. So if you want to say like robbieverse.dev, I want to put a CNAME in there, and I want to reference that to, for example, google.com. That's not going to be possible with a CNAME. It's just like for historical reasons not possible. It is possible with an alias. There are a couple of other reasons, like as you can see on the slides, the penalty charge. So if we have a CNAME record which just links or tells my computer to just go look at another record to find out the IP address, I will have to go through that whole cycle again, right? So if I, for example, link Route 63 to or my domain name to another, or to google.com, right? So my domain name is robbieverse.dev. So we'll have to go through root dev robbieverse and then finally hit Route 63. If Route 63 then tells us, okay, go look at the Google domain, then we'll have to go through all of that process again. So we'll have to ask the root domain servers for .com. We'll have to ask .com for Google, and then we'll have to ask Google for a record, right? So there's quite a heavy like latency fee. So if you have the chance, choose alias, not CNAME. Is basically the main point. There is one drawback of CNAME of alias, and that is that it's only available for AWS managed resources. So if you have application load balancers, you have CloudFront distributions, you have API gateways, right? Those are all supported with alias records. All resources outside of AWS. So for example, on-premise infrastructure, as it was a question before, those are not supported with alias records. But they are supported with, for example, A records, which just is the most basic record that you can have. It just specifies an IP address, right? We have quad A records as well, which specify IPv6 addresses. Then you have like CNAME, which we already covered. You have MX records, which are used for mail servers. So if I want to send an email to robin@gmail.com, then where do I send that email, right? What servers do I reach out to? That's what we configure with MX records. We have NS records, so name server records, which we already covered a bit, right? So those are just references to other DNS servers. And then we have DS records, which are used for DNSSEC, which is something that we won't cover today, but just know that they exist if you ever have to cover DNSSEC, which I hope you don't, because it's pretty like, one, useless, and two, not really that fun to do. A bit complex. Okay. So we'll actually go to a demo now, and we'll create our first record for our RobbieVerse domain. So to do that, we go to hosted zones, and if we register a domain name with Route63, then we'll automatically see that this hosted zone. Otherwise, we just have to create it, right? But in this case, I already created it. And there are 2 records in here already. So we'll actually shut this down. So as you can see, there's a RobbieVerse.dev record of type name server, and these specify all of the name servers that we have, right? That we got back in our DNS response. We also have the start of authority record, which we already saw in our dig lookup. Now we can create a new record, and we can say, for example, www.robbieverse.dev. We can specify an IP address, right? So just an A record, but we can also say this will be an alias. And if this is an alias, then we'll just pick like any one of these AWS resources, right? So in this case, we'll just pick an API gateway. We'll specify the region that this API gateway is in, and we just choose this API gateway. We won't evaluate target health for now, and we'll just create the records. Okay, that's actually pretty quick, right? Okay. So remember when a couple of commands ago we did like this one, right? So dig robbieverse.dev. At that time, it didn't return anything. So what do you think it will return now that we made this change? So again, this is just looking up the information that we just put into Route63. So what will the response be? Yes, you're actually both correct. So both Brad and Hannah are correct. It's somewhat the alias. It's somewhat an IP address. So if we actually look this up, and there must be some caching involved. Or actually, yeah, we'll have to change to www. Okay. Cool. So actually, as you can see, these are IP addresses that it returns. But those IP addresses are because we put an alias in, right? So actually, what we'll do is we'll now take like the IP address that we put in, or the domain name that we put in here. We'll try to resolve that too. Hopefully we'll get the same. No, yeah, somewhat. But yeah, so we get like different responses every time. But basically, what Route63 did is we queried for responses for robbieverse.dev or www.robbieverse.dev, right? Route63 then took a look and said that, okay, this is an A record, so I have to return IP addresses. It then resolved this domain name itself. So it actually looked at the IP addresses for executeapi.eust1.amazonaws.com. And that gave us back our 2 IP addresses that we see here, right? So you're both correct. Yeah. Cool. Great. So let's cover another feature of Route63, which is health checks. And health checks are actually quite an interesting feature, and it's something that you won't see a lot with other DNS providers. It's actually quite unique to Route63. And what health checks are used for is to, check the health of your resource. So check the health of your IP address or of your domain name, right? Is my domain name still available to the public or not? Why this is useful is because when our domain name isn't available anymore, so when our IP address just becomes unavailable, either because we did something wrong on our side or AWS had a failure, which is also possible, then we don't really want to tell customers and tell clients that they should connect to this IP address, right? We actually want to take that IP address out of circulation and actually don't hand it out anymore. So what we can do is we can configure a health check to make sure that we don't hand that IP address out anymore. And we'll do that in a minute as well. So we actually have a couple of routing policies which tie in greatly with health checks. And the one that I really want to highlight is the failover one, which we'll configure in the demo as well, which will just say, okay, if this resource is not healthy anymore, just don't give out its IP address, and just give it the IP address of a secondary record, right? So this is really useful for multi-region applications, for example. So if you have an application in one region, in Ireland, you have an application in North Virginia, and you want to make sure that if the whole Ireland region goes down, which is very, very rare, but in that case, right, you want to fail over to another region. So this is actually something that can be quite useful for. And that's how Netflix also has like very, very high availability of their infrastructure, because they use this concept, right, of failing over using DNS. Latency-based routing is also quite interesting. So actually so if you have, again, multi-region applications, so an application that's running in both Ireland as well as North Virginia, as well as Asia Pacific, right? And you want to make sure that your users can connect with the lowest latency possible, then latency-based routing is great because we will actually return the IP address that is closest to the user. We also have like multi-value answers, so that that's what you saw with like Amazon.com, right? We got multiple IP addresses, and even with www.roviverse.dev, we got multiple IP addresses. So in that case, our computer will just pick one of them randomly. Geolocation, also quite interesting, especially for if you have certain restrictions on, you can't like let certain customers access your infrastructure in certain countries, right? So some countries are banned from using like certain websites. So geolocation routing is great for that. Weighted routing is also an option. So with weighted routing, you basically say like, I want, this part of my infrastructure to receive 75% of the traffic, this part of my infrastructure to receive 25%, and that way you can do it as well. And then you finally have like simple routing, which is what we just configured, which is just very, very simple, just one record with one answer. You also have advanced traffic policies, and that's where you actually can combine like those routing policies. So you can first check the geolocation, and then based on the geolocation, you can pick one of the regions. And so, for example, this is Ireland, this is North Virginia. You can, for example, say if this user is in Berlin, Ireland will probably be closer. So let's pick the like this one, and then like to drill it even further down, let's hand 75% to this fleet that is auto-scaling, and 25% to this instance. Okay. Does a geolocation have additional fees? That's a good question. I'm not sure, but we can actually look it up. So let's do Route 53 pricing. So let's see. we have just a price for so many million or 40 cents per million queries, which is actually very, very cheap. And we do have a bit of additional fees or a bit of extra cost for latency-based routing and GeoDNS. But again, like it's very, very small, right? It's like 60 cents, so a 20% extra per million queries. So quite affordable. I don't think this will be a deal breaker for any sort of infrastructure. Okay. Cool. So let's do some failover. So in this case, we have 2 resources deployed. So we have this API gateway with Lambda function that returns it works. We have this API gateway with Lambda function that returns failover works, right? So what we want to do now is we want to make sure that RobbyVerse.dev, which is currently pointed to this API gateway, that this returns, and it's actually quite small again. Let's see if I can zoom in. Okay. We want to make sure that when it works, doesn't work anymore, that it fails over, right? So what we'll do is we will first create our health checks. So we'll create a health check. We will name it web1. We will monitor an endpoint, and that endpoint will be so that will actually be the domain name of our API gateway. Let's remove the HTTPS. Let's monitor port 443. And just leave the path empty. So we'll flap out advanced configuration as well, because we want to like fail pretty fast so that we don't have to wait for a long time. And we can create the health check. So what this will actually do, if you go to health checkers, is it will actually test this endpoint, so this API gateway endpoint, from multiple countries in the world, right? So it will test from Oregon, it will test from North California, from North Virginia, from Ireland, and from Tokyo, right? So in a minute, you'll see, indeed, success. So this endpoint will become healthy fairly soon. We'll actually create a second health check for the failover. We'll also do domain name. We'll specify the API gateway for our failover API, which is in North Virginia, by the way. So we have one API in Ireland, one API in North Virginia. And we'll actually also go to advanced configuration, set this to a very fast one, and then create the health check, right? And by now we see that Web1 has become healthy. So that's good. So now to configure the actual DNS records. We can go down here. And we can actually change this one. So we can go to edit record. And what we'll do is we will go to routing policy. We will change this to failover. We will make sure that this one is the primary, and we will associate it with health check web1, right? So whenever this resource, so whenever like this health check becomes not healthy, it will fail over to to the secondary record, which we still have to define, right? It will stop handing out the IP address of this API gateway. We will put in primary as the record ID. Record. Okay. So now we have changed our routing policy from simple to failover. But now we still have to create another record, which is again, again an alias, but now we have to point to the alias or to the API gateway in North Virginia. Okay. We'll choose this API gateway. And again, we will choose failover routing. This time it's secondary, right? Because we want to failover. We don't want this to be the active one. We want this to be the passive one. And we will associate it with the health check failover. Also give this a record ID, failover. Okay, great. So now we have these two records. And if we go to www.ropifirst.dev, it still returns it works, right? So what we'll actually do is we'll go and make sure that our health check doesn't return healthy anymore. So port 443 is just the port that API gateway is listening on. So as you might know, port 443 is commonly used for every or any like traffic that goes over HTTPS, right? So HTTP traffic that is secured with TLS. And so that's like port 443 is just the port that API gateway is listening on. So that's why we also put in our, health check port 443. Because otherwise, if we just put port 80, API gateway might not be listening on that port, and therefore it will return unhealthy, which is something that we want to avoid. Does that make sense? Yes, so the failover will work if the client is using like a DNS server with cached values. However, it will have to live through the TTL, so the time to live, which is specified. Usually you have to specify it in your hosted zone. So if you actually go create a record, and it's an, let's see. And it's an A record, right? You have to specify the TTL, so the time to live. So how long does this cache have to cache the information for? We set it usually to 60 seconds. But if it's an alias record, it will automatically assume the TTL of the destination record. So of API gateway in this sense, or in this case, which will probably also be 60 seconds or 300, not sure, but yeah. Will be something like that. So yeah, the best case is if you're planning to fail over or you're planning to do like a change to DNS, change the TTL first to a very, very small value so that clients are very quickly refreshed. Okay. So what we'll do here, and I know we just have a couple of minutes left. Just want to show you that, it actually fails over. So we now disabled the endpoint for our API gateway. So what we'll see is that our health check will soon start to fail. So if we actually take a look at Web 1, we go to health checkers, and we will see failure, HTTP status code 404, not found. So if we refresh again, it can take a couple of seconds, but soon it should return unhealthy. That's the pleasure of doing live demos. Yeah, so it returns unhealthy, right? So now we have to wait for like a bit. And we see that our failover worked, right? So we still browse to robbieverse.dev, and now we see that failover works. So that's great. We're right at time. I actually plan to cover like something else, like something a bit behind the scenes. I'm afraid we don't have time for that, but we'll make sure that we, send across the slides if that's possible, so that you can browse through it on your own at a later time. Are there any last questions? Or general thoughts? Also welcome.
Can you tell us a little bit about yourself and what you do with AWS?
Sure. Yeah. So my job is, as I mentioned, solutions architect. So what I do is I actually work within the sales organization, which sounds a bit scary for like technical people. But it's actually really being a trusted advisor to customers. So when customers come to us, like usually it's like building relationships with customers first of all, and making sure that they run optimally on AWS. So we usually do a lot of architecture reviews. So we take a look at what customers are actually running on AWS, and that can be like Route 63, that can be like a combination of EC2 and Lambda and EKS and so on. And then we do suggestions on how they can optimize that, both in cost as well as performance, as well as like reliability, right? So we take a look at all of those areas. That's a major part of our job. We also take a look at more strategic business outcomes for customers. So we want to do something with machine learning, but we don't exactly know how. That's where we also assist, like telling about the AWS offerings that we have and how we can help.
Great, thank you so much. Great job.
All right. Thanks a lot, Robin, for the great session. And I really appreciate everybody attending this session. And the recording of this webinar is going to be put in the webinar module of your class inside the Canvas. Please look out for that.
Okay. Thank you all for your time.
Yep. Thanks, Robin. Thanks, everyone. Bye-bye.
Bye.
Bye.